My name's Dom Robinson. I'm one of the contributing editors and writers for Streaming Media. I've been writing for the magazine since 2002. Bit of a background, I've been streaming and webcasting since the mid-90s. I suppose if you include playing with telescopes, then it goes back to the beginning of the 90s. Very slow frame rate on telescopes. Spent 10 years building a CDN over in the UK and then moved into building a microservices architecture for all sorts of stages of the live streaming workflow and so on. So it's kind of home territory for me. The industry's definitely moving that way as a whole. Can I just get a quick show of hands? Who has already got a microservices architecture up and running in their infrastructure? Okay, this is good. Who's on the way there? And planning and building one? Okay, so you're either doing it or you're not doing it. Okay, and who's not doing it at all and thinks it's a bad idea? There's one. Okay. So so about a year ago, 18 months ago, Eric asked me to put an article together about OTT and microservices and so on. The article was, for some reason or not, reasonably popular, and so we decided to do a panel session at Streaming Media West on the subject you see here, OTT and microservices, and it was really popular. So we've repeated it at Streaming Forum, and just to complete the world tour, we're now into the third one here at Streaming Media East. So it's clearly a topic of the day. It's clearly of the moment. You can see all sorts of industry sectors are starting to look at microservices architecture and how to deploy microservices and so on. So today's panel, we've got some excellent panelists who know the space, who've been in the space for a while. We're going to take a deep dive into OTT and microservices, the specific juncture of the two, but we will start with some more broad stuff and so on. So with no further ado, I'm going to ask the panelists just to introduce themselves one by one as we go across, ideally with a little bit of a focus on why you're interested in microservices as well. So Sujana, please.
Sure. I'm Sujana Sooreddy. I'm part of the Media Cloud Engineering team at Netflix, and we build a platform on which all the services run, which so anything you see on Netflix, the encodes have been gone through our platform. That's what we do. So in particular, why I like microservices, I like it's because of the faster ability to development cycles, like how fast you could develop and the faster deployment cycles that comes with it. So that's make it microservices special for me.
Excellent. Mark, please.
Hi, I'm Mark Myslinski with Imagine Communications. I work in the targeted delivery solutions division. So for those of you familiar with the SET-130 model, we virtualize all those boxes, and we virtualized our first product. We've now taken through containerization and microservices, and we see massive benefits associated with that and intend to follow through with our roadmap on our other products.
Perfect. Paul.
Paul MacDougall with Bitmovin. We've been using microservices really as the foundation for a lot of our products, and that's what's let us achieve very high performance and scalability and the flexibility to deployment in the development cycles as well. So we've really gotten a lot of value out of that.
Perfect. Rob.
Yeah, my name is Rob Colantuoni. I'm a principal architect in the Advanced Services Division of Limelight. I'm primarily interested in microservices and essentially containers because we have customer demand for deploying these types of functions on the edge, and that's been my primary focus at Limelight for the last 2 or 3 years.
Okay, perfect. So let's start with 101. Let's start with what microservices are, and just as an advance warning, I'm going to go on to the second question: is what isn't a microservice? So Sujana, do you want to take us on sort of beginning of that journey? What do you think microservices? What is microservices to you?
Sure. When I think of microservices, like the two things that come into my mind are the speed and the flexibility. So like when we say microservice, I would say like your entire application, like it's decoupled and decentralized into multiple services, and each of these servers, which is small and has singular responsibility, and all of these things work together in an ecosystem. That's the whole part of it, is what I would call as a microservice architecture. So what does microservices bring into play? It's like the speed of the development. Like let's say if you're responsible for the only single service that it does, let's say in a video world, you're responsible for a service which does only one particular encode with one particular codec type. Imagine the flexibility that it gives. So imagine the fast deployment cycles that it would provide for, and for you to not think about breaking some other parts of the code. So that's like what I would call the microservice architecture would be.
Perfect. Mark, anything to add?
Yeah, well, I have some similarities, but I always think of it like where software's come from, and you have these big globs of software and this big monolithic application, and now with microservices, we take that and break it all up into individual services, and better yet, then you have a way of orchestrating those services different way depending on the need. So,
Perfect. Paul?
see it that way.
I think one of the things that really is advantageous and what makes microservices what they are is that it's the narrowing the scope of responsibilities, and that allows specialization, and it allows iteration without having to impact those things that surround it, and that's what has really been an important aspect of it.
Excellent. Rob?
Yeah, and to build on that, when you take a service and you thin down the scope of that service, you give it the ability to scale, right? So we see a lot of scaling demands from customers, and oftentimes they're maybe extremely regional, and so it gives you the ability to scale up demand in certain regions as your edge sees that demand.
Okay. So let's just get this one out of the way because it needs to be done. What's not microservices? There's quite a lot of different ways this one can go, but anyone want to pick the ball first, or I'll just sweep from left to right? Okay, we'll go with Sujana. Sorry, Sujana.
No problem. So what is not microservice? I think I can say like the common misunderstanding of microservices versus a monolith, or like when you distribute a monolith, it is assumed that it is a microservice. So that is something which I say it's not a microservice. When I say a distributed monolith, it's like you have one particular application deployed, like every individual component is deployed separately, but all of them are very tightly coupled. If one cannot run if the other thing has changed a little, or like it is not deployed, or it's like all of these things are tied together but deployed separately, even those are something which I would say it's not a microservice, which is a common misnomer everywhere where we assume a distributed monolith as a microservice. So that's not what a microservice is.
Sounds good. Mark, anything?
I'll make an observation, see if somebody tops it off, but even in some of my research getting ready for here, I found it interesting. I had always heard of services-oriented architectures, and then I read that services-oriented architectures aren't necessarily a microservices architecture. So I'd be curious if somebody on the panel would tell me why that is.
Okay, that's good. I like that. We'll put that to the audience in a minute. Paul?
Office 95.
That's cheating.
Yeah.
That's cheating. That's not even software, to be honest.
I think today you look at so many of the successful apps, it kind of becomes hard to bring to mind, at least in modern day, a piece of software that isn't driven off of microservices. Because if you're going to be successful these days, that's really the only option that lets you scale and get recognition. So I would say that there are probably thousands of examples that have fallen by the wayside that would be difficult to identify or unfamiliar to people, that because they went a more monolithic route, they were never able to achieve scalability that led them to be successful. So it's almost mandatory in the modern era, I think, to do that.
Cool. Rob?
Yeah, I would say a microservice with a very heavy client library is not a microservice. So I'm kind of building on what was already said earlier, but when you have an extreme coupling of the client logic and the server logic, the benefit of microservices kind of goes out the window. So some of the mistakes I've seen with implementations of microservices is this kind of tight coupling between client code and microservice.
Okay, and one last tricky one before we get into some more fun ones, okay? Is a container a microservice? Feel free to go first if anyone wants to go there.
I would say probably, but not absolutely. I mean, there's certainly,
not necessarily.
it's definitely a framework that makes it, much easier to do that. It's probably the, most influential, architecture for creating microservices. It's not certainly mandatory that a container be a microservice, though, but it's probably the foundation for modern microservices.
Yeah, anyone want to add on that?
Yeah,
Mark?
but I contest you could take a piece of some monolithic code you have and put it in a container, but it's not necessarily a container that could get to all the benefits of a microservice unless it was developed as a containerized piece of code from the get-go.
Okay. Any more thoughts, Rob? Sujana?
Yeah, well, essentially, so yeah, you can utilize containers for microservices, but that doesn't necessarily mean that every container is a microservice in itself.
Okay, cool. So anyone want to add anything?
Yeah, I think I agree with that thing. Like a monolith can basically be put in a container, like parts of it could be put into a container, and then that could basically run on itself, but it doesn't necessarily be a microservice. It's the other way around. Every microservice can be containerized, but anything that's containerized is not a microservice. That's
I'd
how
go
I
with
put
that
it.
answer, yeah, absolutely. So one of the ostensible benefits of microservices is if something breaks in the chain, you don't have to take the whole chain down and redeploy the whole chain. So what are the, sort of thinking about that, what are the challenges in moving from a monolith-based architecture into a microservices-based architecture? I think it's a very broad question, and we can go around this a few times and iterate. So, anyone want to take the lead on that one? Or
Well, I'm going to cherry pick then. I mean, so we have certain products, and we're building certain solutions that in Imagine, and we want to start heading towards containers and microservices. Yet we've got our project deadlines. So. How much of it can we take off and take the big bite and build true containerized pieces of code versus first we have to containerize the monolithic code and then go from there. So just how do you take what you have and get to where you want to get to while still maintaining your current commitments for building out product?
Mm-hmm.
Yeah, very specifically, some of the things we've seen internally for our own internal kind of migration to microservices is like a lack of internal API versioning, right? Mm-hmm. So when you don't necessarily have API versioning, it tightly couples your end client application to that monolithic application. And so what we've kind of found as a prerequisite to moving to microservices is going through the code base and starting to at least initially version out our APIs. And then what we can do is with the versioned API base, we can then increment those versions to point at microservices and start segmenting out those individual monolithic pieces into microservices. But that tended to, for us at least, tended to be a prerequisite. Otherwise, you have too many things you're trying to change all simultaneously, too many pieces, and it inhibits the movement forward. So we found that as a useful prerequisite from moving from sort of a monolithic type of application to a more microservice-based application.
Cool.
Sujana? Yes. What I found the difficulty, moving from microservices, especially for the video, was the testing part of it. When there are microservices versus monolith, our testing framework with monolith was you run an entire encode to see whether it is playable and it is working or not. But when it comes for microservices, what if the encode that's produced is not working in the packager that it is going to be put in? How do you test these kinds of things when everything is doing what it is doing correctly, but put together whether it's working or not? And even if you test, but what if it has already been deployed, the new service came up and it is producing something different and it is not working with the existing ones? How do you test all of these three things together? That was the major challenge, I would say, with microservices.
So you need a deep layer of introspection to be able to get down into those core things.
I mean, from our perspective, especially at Bitmovin, we built our software from the ground up in microservices, so we haven't had to deal with some of those challenges. I've certainly seen competitors, though, that, as they go through that process, they have to, re-architect a lot of assumptions they made in those monoliths that, there are advantages to, having some things work in a monolith environment. You have easier access to things. You don't have to think about how you have to model those out and make those portable to other services. And when you go through that process, you can sometimes see loss of functionality and things that your customers expected from the earlier services that you can't pull over as easily until you figure out how to make those definitions, make those things communicable to the new components that you're building out.
So I remember probably a bit more than that, probably 8 or 9 years ago, speaking at a conference in the UK, looking at the emergence of IP in the broadcast industry, and I remember the question was put to me, what do I think the biggest challenge we're faced with? My answer at the time is it's entirely cultural. I think the technical challenges are broadly kind of resolved and so on. With the specifics of microservices, I think it breeds a completely different approach to engineering and architecture and so on. And for companies that have been developing monoliths in release cycles in particular, actually moving to a more DevOps model is quite often a significant cultural change. Is that something you've seen either inside your organisation or with your clients? And have you got any sort of stories or insights into that experience amongst you?
I think there's definitely a lot of apprehension around that. There's the video workflows have been things that have been very sacred and very guarded by a lot of the engineers who have built them out, because they're usually mission critical workflows for many of these companies, and the notion of introducing fundamentally new concepts is very it's scary, which is understandable from such a big change in your base architecture, moving from baseband video to IP delivery and so forth. So there's, as your point is, culture is definitely a big challenge there. I was at the Avid Connect event just before NAB, and it was sort of surprising to see some of the concerns that people had about moving to the cloud. Cloud obviously being not necessarily microservice, but quite frequently so. And that there were a lot of concerns about, moving things off premises and, moving things out of your data centers or moving things out of your NOCs and so forth, that were, misattributed fears, I think. Things around security that, people have this notion of, having something on premise being more secure, which isn't necessarily the case in, many real world environments. So that we see things like that. We see concerns around bandwidth that, again, when you actually do the math on it, isn't necessarily as real of an issue as perhaps people think it is. But these are all, to your point, very much cultural concerns.
Have you guys had that, other speakers, have you had that in your companies or with your clients?
Sure. It was, we are like moving into the microservices, especially for the video workflows. When it comes to the cultural, I would say like microservices bring in this cultural thing, like every developer is kind of acting as a full stack engineer at this point when you're doing a microservice. That's kind of like where I have seen the challenges of like, major part of it was like testing. How should this particularly go? Like with the monolith, someone else is doing the testing for me. Someone else is deploying everything for me. With microservices, it's not the case. So we definitely saw that cultural problem where like, an engineer has moving right now from like a person who is doing a specific function to a more of a full stack engineer. That was the change that we have seen.
Well, I found it interesting, at least to imagine, and some of this is my learning curve on its own, but I'm used to older days where engineering develops something first and then they hand it to operations and operations operationalizes. But now there's an agile relationship between engineering and operations, and they're both working together from the get-go. So right there's a different bit of a mindset I found interesting. Also, just the whole concept of microservices, which your applications now become optimized for use of the internet and for cloud topology. So it kind of opens up options you have for implementing the apps to begin with, and that's going to be a bit of a change, I think, too.
Okay, before I move on, any other?
Yeah. So internally, I think we already had some microservices like our transcode layer, those sorts of things that were tacked onto the macro service per se. So I don't think there was as much of a cultural shift internally. I think everyone saw microservices as a good thing. Customer facing, there was a cultural shift in the CDN industry, at least, where, whereas we were used to treating the services as an origin per se, and now we are at this point where we are pushing these helping customers push these microservices out towards the edge, right? So the execution of these functions is not happening as much near the back end of the transaction, but it is happening on our edge towards the customer. And so that, for me, that's been the biggest cultural shift surrounding microservices, at least on the CN side of that.
Yeah, your colleague Neil gave a great presentation on Monday about what I'd call fog architecture starting to emerge in CDN.
Correct.
And I think that's really exciting stuff. I think that's going to be the precursor to mobile edge compute, to deep field edge compute processes and so on. So.
Just sort of following up on that to the cultural point too, I think there's another notion of, there's a very human attachment to a physical device. I know that box is doing that thing. I can go touch it. If it's breaking, I can go pull it out of the rack. That kind of less tactile, that notion of I don't necessarily know where the thing that's doing the thing physically lives is, again, sometimes intimidating to, people that they don't have that sense of I can go grab that server if it's not behaving right and throw it in the garbage out back.
We've got a very brief story we often give. We do a lot of transmission work for a broadcaster in the UK, and they're so set in their old school ways that when we set up their private cloud in their facility, they wanted to be able to bring their broadcast clients around and point to the server that was operating their stuff. And we couldn't, so we came up with this, and it didn't make any actual architectural sense to do so. but they just sort of requested that we did. So we have this concept of a preferred encoder, and then we gave them a label gun and said, "You can stick this on the top."
This is where your box lives.
But it's a strange thing. They do have that attachment to this. This is your box. This is where it goes. So let's focus on the broadcast and the video space for a little bit. What do you think, as a general sort of generally scoped question, what do you think the real benefits that broadcasters can see out of OTT? Out of microservices? Are there specific things that are better in a microservices world from the broadcaster's point of view, or from the content publisher's point of view?
Well, I just see the broadcast industry in general. We've had to rely a lot on appliances and hardware and FPGAs and all that, and dedicated networks just to move these large volumes of video and audio. So now, if you can get to microservices, you can get to containers, you can get to that which is optimized for the internet and cloud topology and IP-based protocols. Now we can get away from the dedicated stuff. Now we can get to cloud topology. Now we have the expansibility if we need that for volumes of processing or volumes of traffic or whatever. I see that as some big benefits. And that then those applications become cloud native as opposed to just cloud enabled. They can run on a cloud. They're cloud native. And the Googles and the Facebooks and the Amazons of the world, they grew up on this stuff, so they're already there. And if the broadcasters are going to try to compete with them, they've got to get to this cloud native kind of applications. I think that's one of the big benefits once they can get there, that they can truly compete with agility and scalability of the big guys that I just mentioned, but they're going to need to do that.
Yeah. So I have a very specific kind of situation which kind of encompasses that, which is we had a customer who was doing forensic watermarking of assets, right? They were distributing 5,000-6,000 copies of a particular movie out to a certain subset of users that they needed to forensically watermark, right? And so their traditional methodology was to take this and make 5,000 copies and then distribute it via the CDN. And so the CDN was delivering 5,000 individually watermarked copies of these videos to customers authenticated. And so we worked with them to essentially create an edge function as a service that would then essentially do the meshing of the forensic watermarking on the edge, right? So instead of pulling 5,000 copies of this asset from their origin, now we're pulling maybe 2 copies, and we're distributing 5,000 or potentially an unlimited number of copies by doing that forensic watermarking on the edge as close to the end user as possible, instead of doing it in the traditional model, right? So when you start to take these small little functions and start to deploy them on the edge, you open up the not only the possibility that you need to not have as large of an origin, and you don't have to have all the functionality on your origin, but you start to distribute less content and start making the edge smarter and allowing for these kind of additional services to be essentially drop in place.
Even with just like broadcast channels, if you have one channel that needs to be branded 5 times with 5 logos, we traditionally would have to make 5 channels, but now you can make 1 channel and just brand it 5 times as it comes
Just
out.
branch that one point in the microservices frame, yeah.
I think there's also some big advantages around, the scalability. There are quite frequently, you might get a new initiative that we need to put content on some other platform or something like that, and the time frame of that might be something where you have to, scale up a lot of resources, especially if you do that with a monolithic architecture. You have to scale up aspects of your application that aren't necessarily beneficial to that process. So you might be able to take a more, an older school transcoder and put that on a VM and spin up 1,000 VMs to do that. But quite likely you are replicating services, you're replicating software and components and so forth that are using resources that aren't beneficial to that overall project. So there's that efficiency loss. There's the the ability to iterate, of course, new versions, testing out just the component that you need that new feature on is very powerful, especially with our market, constantly releasing new HDR formats, new codecs, new, all kinds of new bells and whistles all the time. And then the last one that I think is a big trend that we've seen a lot lately is the isolation of responsibilities between different departments. So something that some of the especially larger broadcasters have done, they have the IT department, that single responsibility now becomes just installing servers. Even if they're not going the cloud native route, they're going and just racking generic CPUs in some data center somewhere. And the fact that they can be abstracted from what software is running on, the considerations that might be unique to that software because it's running on some sort of microservice, some sort of container architecture means that they don't need to get into the nuances of what that application requires.
It's interesting talking to Sujana's point about each engineer has to be sort of have a full stack expertise. At the same time, the infrastructure on which they're working has become much more separated and isolated.
Yeah, that's interesting. Yeah. So we did something similar with like image specifically. Previously, we had the cold feed of images which had like different derivatives of like, there's a single image source, but there's like multiple copies of it which has Netflix branding and the language specific title information on it. But with this microservices, there's like only source images present where we are streaming those images, and there's a composing service. All it does, it's like composes images on fly, and the scalability needs are very different. Like for something where you get the images versus us composing of images. Memory needs are different and the CPU needs are different. So now this composition happens on the fly. It's scaled as per the needs of the customers of the whole Netflix. So the scaling needs have become very different. The caching needs have become very different. So embracing this microservice architecture makes you think in a way different, like how to save space for the cold feed versus develop these images dynamically. So that's how.
I think to an extent, I think microservices architectures are letting almost every single stream that's delivered become more personalized to its target rather than personalized from the origin, if you see what I mean. That's probably not the best way of phrasing it. But. So can you maybe each give us a couple of minutes of a description of how you have architected your particular frameworks? I don't want to sort of say business or project or client services or whatever, but can you just give us just a quick description, mention some of the technologies you've used, if they're third-party technologies, how the architecture sits together and how it's been put together. I think I'm going to let Sujana come last because I'm sure people are very curious about the Netflix one. So let's start about it.
Yeah, so she'll blow us out of the water.
Yeah, it will scare us a bit.
So the way we came into microservices, and it was strictly, and obviously we've had some challenges internally moving to microservices and those sorts of things, but where for me the most focus has been is a function as a service on the edge type of execution, right? And so some history here, for many years we were running as a traditional CDN. We started to introduce what we consider to be like edge logic, which was a which was a per request execution, right? So again, stateless execution of a small piece of code. Typically, customers are using this to do very simple transformations of HTTP content headers and those sorts of things. But then, as the customers began to expect kind of more out of this, you have to move to more of a function as a service type of application, right? So now we have like it's virtualization, right, with containerization built inside of it, strictly because what we needed was a VM to segment out, customers, to provide customer segmentation. So we exist in an environment where not all of the code that's going to be running on our edge is necessarily going to be have shared ownership, right? So we found that just strict containerization was just not sufficient for what we wanted to do. So what we'll do is on a customer request like function as a service, we'll spin up a VM. And then within that VM, then there will be individual containers on a more per function basis that will be spun up. But this happens extremely quickly, and then those VMs have a certain life cycle that they live out on, right? And then this is distributed across the edge on in all of our data centers and POPs and those sorts of things. So we've started to go that's the route we've been able to go to, and then now we're at the phase where we're migrating a lot of our traditional request loop processing over to the function as a service layer, and it's been fantastic. We can also use that function as a service layer not only on our HTTP infrastructure, but we started to look into integrating it with our storage platform. So if we have callback functions on our storage platform, so you could drop a video onto the storage platform. There would be a callback to the function as a service layer. It could say, hey, this MP4 video was just dropped. Now we're going to do some sort of video video transcode of that particular asset into HLS or something like that. So we're building it in a way where it's those microservices can be utilized not only on a HTTP request basis on the CDN, but then also on like a storage callback or some of our other video services. So we think it's turning our workflows, it's making us be able to deploy much more flexible workflows for customers.
Perfect.
So I think the product that we have that showcases the microservice architecture the best is our transcoder. What we've done is we've granularized down the microservice level down to basically the output GOP level. And what I mean by that is we can actually take based upon the user's profile, the output profile, we can create a microservice essentially using Kubernetes primarily, but we use some other architectures too, to make each one of those output GOPs run its own transcoder. And what this does is it gives us a bunch of advantages. It lets us very effectively scale resources. So a customer is really only limited by their ability to pay for CPU cycles and their ability to or rather their business needs. And so how much power do you want to apply to, for instance, a transcoding job? So we can do things like scale up enough resources to do 100x real-time H.264 transcoding, or do 4K adaptive multi-codec in the cloud, because each of those GOPs is being worked on independently. We can just throw more resources at it to do tremendous amounts of processing on it. It also gives us abstraction from the underlying hardware, so we have very flexible deployment models. We can go from AWS to GCP to physical on-prem and so forth there. We've also built in failure of the microservice as a underlying notion, so things like spot or preemptive instances can be utilized very effectively, because we can say that that particular GOP might fail, and then we just redistribute that tiny little grain, that one little microservice somewhere else, and that gets us access to very cost-effective CPU cycles. And then, lastly, of course, the ability to iterate on development, to roll out a new feature, something we can do now in, weeks instead of months, because, we can just update one version of the encoder. A customer can test out just that one version with one API request. And they don't have to worry about their production workflow being interrupted. They don't have to upgrade an appliance or anything like that. It's just for that one use case, that one test, they can go.
Perfect. Mark?
Well, I haven't had to manage a product or a project with developing microservices. I know at Imagine we have one product that's full-fledged microservices. It's called Zenium. It's Zenium, if anybody cares to look it up. And it's made possible what traditionally has been always an appliance product, which is for playout and origination. Now it can operate in the cloud. So I can see the clear benefits of it. And I know we're going to use that as a model for actually one of my products that we're going to just now start taking to microservices. If you ask me that question this time next year,
Perfect. Well, we'll get you back.
I'll have it for you.
We'll get you back. Brilliant. Sujana?
Yeah. So I would say we are moving to microservices for the video workflow. I wouldn't say we are there yet, but our architecture, most of us it is in-house built. We are not using much of open source technologies here. But what we do is we build functions which has, again, containerized, and now this functions gives you this notion of layered development of things. So we have a platform layer which brings in everything for a media function to run, and then the media engineers actually work on their media code they have to write. And then we have workflows, where our workflows are more data-driven workflows. So we have our in-house rule engine, which works based on the data that's provided to it, and then we have on top of it, we are using RPC calls more than, we are moving out from the REST to the RPC way.
That's interesting.
Especially for the one problem which we faced with REST was not having the data models. I do not know exactly what the data model was. It's a free-form JSON. But now with RPC, it comes with very strict contracts, interface contracts that you could communicate with. So we are using RPC framework, especially for communication. So all in all, I would say when I say a microservice in a video world, it is basically a combination of three components: your workflow, your functions, and then on top of it to communicate an RPC layer out of it. So that's how our architecture is defined.
Almost perfectly segued me to my next question, which was orchestration. So to talk about orchestration strategies, we're now dealing with thousands of tiny little things rather than tens or hundreds of larger building blocks. So orchestration is a critical part of bringing those Lego bricks into look like a model. per se. Talk about your orchestration strategies. You've sort of touched on it with this with RPC against REST, which is really interesting. But what is your orchestration strategy? How's it deployed, and what are the sort of key elements in that deployment? Do you want to sort of continue, because it sort of feels like it continues on from the RPC stuff?
Sure, yes. So the orchestration we do is basically, it's database orchestration. There's like two kinds of orchestration that you could do, where you could say, hey, run this followed by, run A followed by B followed by C, where it's like a very statically defined workflow. Or it could be a dynamic workflow which says, hey, if let's say this particular encode has been requested and this inspections are complete, then run my particular workflow. So we went on to the approach of using data-based workflows orchestration than a statically defined workflow. The benefit of data workflow which we saw was the ability to add new things in a way which wouldn't break the existing ones. Mm-hmm. And also the easy notion of adding it. It's like, it's mostly dependent upon what the next thing to be run is mostly dependent on what data has been produced so far than what it has been run so far. Different systems could run previously, but if the data that it produced is the same, the next system will run based upon it. So that's the approach we took when we basically did the orchestration layer of these services.
Cool. Let's keep going, Mark.
So I can give you an example. I did have a luxury a couple of years ago working on a project where we harnessed virtualization around a satellite link, both at the uplink and the downlink. And where I find that interesting is, I mean, that's a big investment to get satellite bandwidth and service, and as well you usually have to commit to how much bandwidth you want from that satellite link. But in this case, we had virtualized the uplink and downlink. In this case, we would only encode, in this case, channels that were delivered to affiliates. We would only encode those channels up over satellite that were needed and not sending any that weren't. So that bandwidth could then be shared by other customers conceivably. And same thing, and so there was a layer of orchestration there just to manage if a channel is being called for, we want to spin up an encoder, we want to send it over the link, and if you don't need it, you can tear it down. And same thing at the on the downlink side of things, that we virtualized just-in-time packaging, and with that, we could handle the ebbs and flows and increased unicast traffic via orchestration that was happening at the downlink. Or in other cases, you might take a downlink that has a certain purpose during the day and requires certain processing during peak times during the day, but then you can repurpose that hardware at night. Let's say if you've collected a bunch of data for Internet of Things, and then you can do some offline processing at night before you end up sending it back. So, orchestration just gave us that flexibility to use that satellite link. It changed the nature of the satellite link that was being used. And on top of that, if a satellite supplier so desired, they could sell those processing services, or they could sell bandwidth dynamically now as OpEx instead of being a static, something static, or as CapEx.
Interesting. Paul?
I think some of the stuff that we've done with our, especially like our scheduling and orchestration is, that it's video aware, and it understands things like GOP structures and what that's going to mean in terms of the resources that it's likely to need, from the job that's coming through. So when we get an input file and we do an analysis step on that, and we understand what the output profile is, we know how many containers, how many services we're going to need to do that job, and our scheduler then goes requests as many resources. And kind of on a funny note, we actually have gotten calls from Amazon and be like, are you sure you meant to request that many resources around that? But it's fascinating to sort of see that these things that are otherwise meant for some architectures can easily be repurposed to the nuances of video and leverage resources in ways that a traditional scheduler that's looking for utilization or something like that might not be as appropriate for.
And you use Kubernetes for orchestration?
For some instances and stuff like that. There are a couple of different models that we've gone that route.
Interesting. Okay.
Yeah, so our function as a service layer, we built an API around it for the orchestration portion, where you're pushing out and updating code updates, right, on a per customer basis. On the resource utilization side, when the customer pushes out certain functions, they can ask for certain levels of resources that are associated with those functions based on how much compute and memory they're going to need for those particular functions. And then on an individual, on a micro orchestration portion, we tune the VMs to have a certain lifetime, right? And that's based on what the request rate looks like on the edge, right? Because we're deploying these things on the edge. We may spin up if we have that set too low, we may spin up a VM and then, destroy the VM before the next request comes in. And sometimes you want to maintain that VM, have a certain keep alive that will allow you to reduce the overhead of that spin up initially, right? So, that from our perspective, that has to kind of all be automated to a certain degree, and it has to be based on the overall request rate of that customer hitting our edge and what that function is doing.
Perfect. So I'm just going to make sure I have been blinking over here, but I haven't seen any hands go up. But do start asking questions. I'm quite happy to take them mid-flow and so on if there are any at this stage. Cool.
Hi. This question is more specifically for Rob. So when you say deploying functions at the edge, what is the kind of input? Like, is it a container or is it code? What do you?
So when we run our functions on the edge, we are operating in a stateless environment. Stateless meaning we have exposed to us the HTTP request, right? So that is our inputs, and perhaps the HTTP request in the URL there, for example, for forensic watermarking in the URL, there's a hash that's then media vaulted, so it can't change. We then take that particular hash and decompose it into an array, which then defines out what kind of what we're going to be doing with the segment that we eventually return, right? But that is handed off to essentially a customer-specific VM that is spun up, which provides our customer segmentation, right? So we have to assume that all the customers deploying code on our edge are terrible people, and they're going to want to try to affect other customers. So we have to provide that segmentation, and then on a per function basis, then we utilize lightweight containers specifically for the individual functions themselves. So each individual spin up of a function, each individual HTTP request will result in a containerized execution, which will then be routed. The return of that will be then routed through the CDN. There may or may not be an origin request out of that as well, right? So, for example, if we're forensically watermarking a single, HLS segment, we may end up having to go back to the origin to fetch that HLS segment in order to return it, the specific version of the HLS segment that we want to return. So yeah, a lot of moving parts kind of on the edge, but in the end, it works really, really well.
Sorry, was there another hand that went up? There was.
Hi there, Thomas Bowser-Mason. I'm with SMPTE, and I wonder, have you seen in your work if people build workflows with microservices, a mixing of different microservices from different vendors? And if so, do you see any opportunities for standardization in the communication between those microservices?
I mean, I think one of the things, while we did get into some of the vagaries of the definition of microservice around containerization, containerization has been, the standardization that you get with containerization has really been one of the things I think has accelerated microservice adoption quite a bit. The fact that, you can install Docker on your Mac and expect more or less the same development environment with a couple of very small nuances around the networking as you get from having thousands of servers running in AWS means that there is a consistency and there is a, standardization around that. Combine that with the typical communication between those microservices being basically, HTTP, REST-based calls for the majority of cases. I guess there are some other options that we can get into around that for sure. There are some, I think, really reliable standards out there, and that is, in fact, one of the things that has made microservice architecture so successful because it is that, effective standardization. Docker container here is the same as Docker container there, the same, underlying operating system, the same expectations, and so forth.
I think just for my own comment there, I think part of the challenge is when you're doing microservices architecture, it depends how you scope and decompose the problem or break the problem down into its building blocks. We talk often about encoding and packaging, but actually that might not be how everyone breaks their problem down and resolves their microservices. So you might buy an ideas packager and a Bitmovin encoder, but they're not necessarily going to work together because we might have actually broken the problem down in a fundamentally different way. And it's the only thing that's common is the logical architecture of thinking of having an old school monolithic encoder and an old school packager and so on. But those functions they're quite blurred when you get into the microservices architecture, or they can be. So.
What I find interesting, though, is because with the true microservices and having common APIs and using common protocols, that you can optimize what's implemented in those containers with different software. One might be Java and might be C++, and so this could come from different vendors who have particular expertise in something and be completely different software, but they can work in the same architecture.
Does that help? Any more questions on the floor? I've got plenty more myself, but I don't want to miss out. Okay. So data, microservices architecture tend to produce a shed load of data right across the board. I was going to use the wrong term there, but they tend to produce a lot technical term, yeah. But they tend to produce a lot of data, and that presumably is presenting new challenges. Can you guys talk to that a little bit? And I'm going to start with Sujana again. You knew it.
Sure. Yeah, it definitely does produce lots of data. The major problem was like the representation of this data now. Like, at what entity should all of this data be grouped together such that it makes more meaningful sense of data? Do you care about the intermediate data that's produced during encode process? Like, or is that needed for debugging? How do you put all of this data together? That's like one of the major challenges with like microservices, the representation of data together. And I would say like there's another data problem that we would see. It's not like the data affinity. The other thing with microservices, let's say if you want to do something with a source video and now it's split across multiple services, the data affinity is lost. You have to get that source file again and again at every service. How do you solve these cases? So this is like another challenge that I would pose, like how, for the panel too, like how does this get solved too?
Interesting. Data. That's your only part of the question you get repeated.
I mean, it's definitely a challenge for sure. I will say that I think a lot of the more modern cloud vendors have made this quite a bit easier for us. We've seen things like, object storage. Today, the modern object storage makes that much easier to have. For instance, in our case, the massive amount of parallel requests that you have in order to have all these different containers working on it simultaneously. You start looking at some of the earlier legacy protocols for file access and so forth, and they just can't handle that many different microservices requesting that same asset at the same time. We are, again, kind of one of those things where you do fortunately get abstracted from this when you're building a lot of these services these days. Somebody else who's a specialist in that has really focused on that problem, and that's been the scope of their microservice that they've built out. It's somebody else's microservice that really they've, emphasized on, that's taken those data challenges and simplified another developer's access to that, underlying data.
Rob,
Yeah, so we utilize our object store to distribute essentially the copy of the code onto the individual VMs before they get spun up, and so we run our own storage platform, which is essentially an object store at under the hood. And so for ingest data, that makes a lot of sense. For egress data, we for things like asynchronous like, let's say you have a microservice that does a transcode, you want to make an API request, but you can't wait, obviously, for the transcode to complete. There may be outbound data, for example, like a callback, right? So the customer would call something like a microservice to do a transcode. They're not going to wait 6 minutes for the transcode to complete, or however long that transcode took. Maybe what they do is instead they ingest a callback URL, which then, when the microservice is complete, passes data about the execution of that transcode back to the callback, which the customer then can consume and then execute, continue on with their orchestration on their end. So, on the egress side, I mean, we can log all we want, but ultimately we need to be able to expose the individual microservice request data to the customer. In some cases, callback and those sorts of things makes a lot of sense.
Anything to add, Mark? No? Okay. Okay.
I think it's worth following up on that too, that, while there are obviously the challenges around that, the advantages you get from that data are absolutely tremendous in a microservice architecture. If you look at a more monolithic application, you try and understand where your bottlenecks are, where your challenges are, it's much harder to see what's going on inside of that process, versus now you can see what the communication is like, how long did it take for, this component to do it versus the next component and so forth, and be able to, quite easily put that in something like Kibana and see like, oh, this is where our delay is, and we know we need to either, make that part more efficient, or we need to scale up the resources for it. That can be tremendously valuable to a business and being able to, execute more quickly and execute more reliably.
That's huge. Yeah, that's huge. Because, sorry. Go ahead. I was going to say that. Yeah, that's huge because in our existing where we had code executing in the request loop, that execution, the overhead was kind of hidden in our Edge Prism software, execution, data. So by breaking out your microservices onto different platforms, you make them very distinctly measurable.
Right.
And it's a huge advantage.
Yeah. Sujana.
Yeah, so when it comes for data, the other thing which we found useful was tracing capabilities. Like the ability to trace your data, which goes from one service to the other and coming back all of this data together. We found like Zipkin's kind of like tracing with your traces and the spans and understanding the whole graph of the operations that are happening through it to figure out which one exactly failed. So when with microservices understanding what failed, I would say tracing is like one of the best thing that's there to solve this one.
So on top of the microservices deployment, there's then another layer of deployment which is the intelligence or the analytics of that data, just to be able to make the decisions. And are you guys automated with some of that decisioning, or is it highly manual? Or
so for us, like tracing kind of like comes with the box. Like any service that goes that gets deployed has this trace IDs that basically follows from one system to the other. So that in itself helps resolve most of our debugging or like data affinity uses, I would say. So that's what's happening.
And Paul, you nodded there as well.
I think it's, a lot of it is experience, and then you build out based upon that experience solutions and automations for that. So usually the first time you encounter those problems, that's going to be a human going through and dealing with that for that particular use case. But now that you've identified that, it becomes that much easier to go automate a longer term solution for it, a more reliable, replicatable solution for it.
Yeah, and those are all still very highly bespoke to each business at this stage, I think. There's nothing common there. Any more questions from the floor, guys? Don't be shy. Don't be shy.
Thank you. Did microservices transition influence any of like the language level choices and the technology vendor level choices?
I think to a point that was made earlier, there's actually, you get abstraction from that, so you're less committed necessarily to any one language. A developer can make their microservice in the language of their choice, and then another developer can do that as long as the definitions, the understanding of how those services communicate to each other is consistent. You can work in whatever language they're comfortable with. On that note, though, we have seen languages like Go become much more popular because it has so many tools built into it that work very well for microservices and cloud-based architectures.
Yeah, so because you've kind of created a standard interface through HTTP. Again, you have the ability to deploy. Now in the CDN side, we're seeing things like essentially JavaScript is becoming like kind of the de facto standard for function as a service on the edge. Probably mostly driven by AWS Lambda type of interface. But then whether the customers, whether you're deploying something like a node or a V8, those things differ slightly. But I think JavaScript in general is becoming kind of the way that the CDNs are approaching function as a service on the edge, strictly because we give them a callback that says, hey, you've got an HTTP request. We're gonna process your callback, and you're gonna use JavaScript to define how we respond to that object and allow them to pull in libraries and those sorts of things.
Sujana, what languages are used within the Netflix environment? Is it many? Or?
Mostly Java, and we have some in Python, but yeah, that's pretty much like what we use. But when it comes for like the language specification, the other thing which we saw with RPCs was like something like Google Protos, you create the interfaces with the protos, but then you're free to implement it in any language you want. The generators generate your classes in any language you want. And the clients who are using it can generate the endpoints in any language they want. So that's like another thing which I felt like was solving using Google Protos.
Yeah.
I mean, just to speak for our company, we're kind of orthogonal to that in that we're Erlang based. So most of our code is based in Erlang, which itself is my Microservices architecture almost natively, and it's 30 years sort of mature. So it is if you can go down that path, and like we have a small team focused on Erlang, then you actually get a lot of the benefits of containerization, Docker, and all of those, but within one language. It's a different approach, and it's not necessarily as easy to go and hire people as maybe Java programs or something, but it brings a lot of the benefits. So there are some niches out there. Any more questions, folks? Got time for one or two more? Come on, don't be shy. Okay, go back to my list. So thinking broadly out, and not just within OTT, but start within OT, what do you think are the applications that benefit most from a microservices architecture? It can be as niche as you want within the video encoding workflow, or take us out of the streaming context into, I don't know, retail or whatever. Are there other areas that you guys have experienced or found microservices most strongly benefit? Mark?
Well, I'll just reiterate, in the case of we took a satellite link up and down, and just the fact that we could virtualize at both ends, we'd completely change the nature of the use of that satellite link. It was no longer a static resource, and it could be easily repurposed. So anything like that you have to make a significant investment, something that can deliver high bandwidth in multiple edge locations. And so now I would take that a step further with ATSC 3.0 coming. Why not put the same kind of virtualization at the base of those towers? And why not? Now you can certainly better handle ebbs and flows of traffic. The way ATSC 3.0 works, they set up these pipes called PLPs, and they can actually dole out more or less bandwidth depending on what the applications need. And now you have a way to service that bandwidth with the way microservices can scale up or whatever. So, and for the people that provide those tower locations now, maybe they could consider being in the business of providing those services, or providing more or less bandwidth from those tower locations using microservices. So
more competition for Rob.
We're branching.
Have you got any thoughts about where? Let's go from your end, Rob. Have you got any thoughts about where microservices can be most beneficial, and don't specifically speak to OTT if you've got broader thoughts as well?
Well, yeah. So I don't know if it qualifies as necessarily microservices and just like more along the container distribution side of the house, but as the CDNs kind of migrate to this model where we're not as much focused on just strict content distribution, but rather the distribution of logic out to various all of our points of presence around the world and those sorts of things. It brings up the possibility that customers are going to attempt to deliver video using non-HTTP type protocols, right? So we've kind of all standardized on HTTP protocols, because of the CDN industry. We run HTTP proxies. It makes it easier for us to go about and distribute those in a fairly scalable way. But then you have customers who have kind of niche requirements for video distribution, in which case it would be really advantageous for them to spin up globally distributed repeaters for particular, like for example UDP type terminators that would allow them to distribute traffic that is maybe not necessarily HTTP, that is very highly specialized video traffic, right? And so those are the types of things where I could see these function as a service or containerization on the edge being really, really useful in the video space.
Excellent.
As I was actually kind of thinking about the question, I'm almost wondering maybe a better question would be what doesn't benefit from microservices or from approaching things by granularizing them further. You look at sort of, I think, what are two of the most fundamental trends in software development, or really kind of any aspect of technology. And you have two of the main forces are abstraction and amplification, abstracting somebody from the challenges, the underlying difficulties, the nuances and so forth that they don't need to be involved in, and then amplifying their power to, leverage those and, do more with that. And microservices really give you those two things in spades, the ability to develop software without having to be concerned about what that underlying system is, knowing that's consistent. And then to be able to scale that. So again, I think it's almost, I find challenging more to find a place where you couldn't leverage that benefit. So.
Office 95, perhaps.
Thank God it's dead.
Sujana, any last thoughts then?
Sure, yeah. So I would say, like, if you have any system where it could do things later, where it can depend upon the events that are generated by one process and leverage those events, those are the systems where you could benefit by microservices. Any events-based systems, let's say even in the supply chain, if someone places an order, you don't have to send an email immediately in that process. It could wait. You don't have to send the invoice immediately. So all of these, which could basically be leveraged by events, so that is where microservices would make more sense.
Perfect.
So that's what I would say.
Folks, I'd like a round of applause for an excellent panel. Rob, Paul, Mark, Sujana, thank you.